In this video, we're going to set up an input system that will manage all of the input for our player controller. We are going to use the new Unity input system to define input actions for our controller. Let's begin by creating a new script called input system. We will attach this system to the game manager object directly. This is the practice we will follow for all of our game's systems. Let's delete all of the Unity callbacks that were automatically added, and then we'll copy over the managed versions that we defined for our player script, because the input system will also be managed by the game manager. Remember, we are doing this so that we can control the order in which these scripts are executed. Let's also delete this print statement that we placed in the player's awake method. Now, let's introduce a reference to the input system component into our game manager script. Let's also add the input system to our custom namespace before moving on. In the awake method of our game manager, we'll use the getComponent method to locate the input system component because it is attached directly to the game manager object. Then we can call the input system's managed awake method. Notice this will ensure that our input system awakes before the player awakes. We will also call the input system's managed update method in the update callback of the game manager. Now, let's open up the package manager window so that we can install the new input system package. After the installation completes, we will be asked whether we want to enable the new input system in the player settings. Click Yes, and the editor will restart after configuring the new input system for us. You may be prompted to save your scene before the editor restarts. Now, we have the new input system installed and configured for our project. Let's create a new folder in our assets where we can store the resources related to the input system. Let's look at the project settings window to look at the settings related to the new input system. First of all, we can look at the old Input Manager section to see that it warns us we are now using the input system package, so the Input Manager will not be used by our project anymore. Then we can look at the new input system package section to see that Unity has provided us a button that will automatically generate the input package settings asset we need to get started. Click this button and then drag the new asset into the input folder we just created. Inside the input folder, let's now create a new input actions asset so we can begin setting up the actions we will need for our controller. We will call this asset Player. If we choose this new asset, we can select the box that says Generate C# class, so that our input action script will be automatically generated for us after we edit this asset. Now we can click the Edit Asset button to bring up the dedicated Input Actions editing window. This is where we can build our input actions. Let's create a new action map called Player. This is a set of related input actions. For instance, we might have a different set of actions for when our player is accessing the main menu of our game. Unfortunately, the names we chose will create a naming conflict in the C# script that is generated. So let's change the name of the asset to Player Input Actions. Then we can delete the script that was generated for us, and when we save the asset again, it will generate a new script that no longer has this naming conflict. Now, we can begin building the input actions we need. Let's delete the binding that was created for us because we need a binding with a different type for our purposes. After deleting the binding, we can change the action type to value instead of button, and this will give us access to new options when creating a binding. Let's rename this action to Move and set the control type to D-pad. This will be the input action that controls the directional input for the player. Now we can add an up, down, left, right composite binding to our Move action. We will call this binding Keyboard, and we will assign the traditional WASD keyboard keys to each direction. The new input system allows us to use one abstract action in our game without worrying about how the values are being generated. This helps separate the interface being used to control the game from the actions we want to perform in the game itself. The script simply asks for the move action value. It doesn't need to know where that value is coming from, which means we can easily change the input devices later without breaking our input system. Now, let's create a second composite binding that we will call controller. To easily set up this action, we can use the Listen button. This will allow us to simply press the button on our controller that we want to associate with this binding direction. Now we will have two bindings associated with the move action. Pressing the W key on our keyboard or pressing the up button on the controller's D-pad will both trigger the move action to report the up value. Now we will create a new action called Jump. We can leave this action with the button type. We will follow a similar process to how we set up the move action, except for this action will have simple bindings. One of the bindings will be set to the spacebar on the keyboard, and the other will be set to the A button on our controller, which is referred to as the South button in Unity. We now have all of our input actions defined, so we can click the Save Asset button to generate the script that will define these actions as a class. We can now open this C# script to see that Unity has translated everything we just defined into code. It's possible to do all of this by hand as well, but I think you can see why Unity developed the Input Actions editor. Now that we have our input actions defined, we can begin connecting them to our input system script. Unfortunately, while recording this, I am experiencing a bug where Visual Studio closes all of my open files whenever I create a new script in Unity, so I'll have to reopen the input system script now. Let's first introduce a reference to the player script in our input system. We will use the usual approach to retrieve this reference in the awake method. Now we can begin defining variables for the input actions we just created with the editor. First, we'll add a reference to the player input actions class itself, and then we'll define variables to hold both of the input actions we created. In the awake method, we can instantiate a new instance of the input actions class, and then we can get the individual actions directly from this class. They are stored in an object inside the class called player, which represents the action map we defined earlier. We can now delete the managed start and fixed update methods because we won't be using them for the input system. Let's define two private methods that we will use to gather the input values from our input actions on each call to update. We will also include the onEnable and onDisable Unity callbacks so that we can enable and disable the input actions along with the input system component. Let's write the pollMove input method first. Each action has a method called readValue, which takes a template parameter representing the type of the value we are attempting to retrieve. Since our move action is a composite binding with two axes, we are going to get a vector 2 as the value. We'll make sure to call both of our polling methods in update before moving on. In order to determine when the input value has changed, we are going to define two variables to keep track of the previous input value for each of our actions. This might seem like overkill if you have some experience with Unity's input system, because it also provides callbacks that will fire every time the input value changes. This sounds like exactly what we want in this case, but there is a small detail regarding the game controller's D-pad that causes an issue. The input callback that tells us when a button is released on the controller is not fired if we simply slide our thumb from left to up on the D-pad. This is because technically the button is still pressed this entire time. Unity considers the D-pad as a whole to be a single button for the purpose of these callbacks. But we definitely want to know when left on the D-pad is released, even if the player never let go of the D-pad when they shifted to up. We are going to solve this problem by manually comparing the previous input value to the current value. So after we store the current value in a local variable, we will begin a series of if statements to check whether it is different from the previous value on either axis. This will require 3 checks for each axis. A positive x value means the D-pad is being pressed right, a negative value means it is being pressed left, and a value of 0 means it is released. Our first if statement checks if the D-pad was either released or pressed left and is now pressed right. Our second if statement checks the opposite of this. And our last if statement checks to see if the D-pad was being pressed left or right and it is now released. This covers all of the possibilities where we would want to update the X input for the player. Then we will follow the exact same process for the Y value, because we want each axis to be updated independently of the state of the other axis. On the controller, it's possible to be pressing up and left one frame, and then slide your thumb to pressing down and right in the next frame. We will need to define methods in our player script to allow us to actually set these new input values for the player. For now, we'll just leave some comments reminding us what needs to be done. To finish up the input system, we will apply the same logic to the jump action, although it is a little simpler because it is just a button that is either on or off. Finally, we also need to make sure we store the current input values so that they are available as the previous input values in the next frame. That's all we need to do with the input system. In the next video, we will begin building the state machine that will be the core of our player controller.